Perpendicular lines. Key thing to note for perpendicular lines is it's once again all about the gradient. So long as you can do gradient, you can deal with perpendicular lines. So here is a picture of some perpendicular lines. Key thing to note is that they are at a right angle. If you don't have them at a right angle, they are not perpendicular. So these two lines, not perpendicular because they are not at a right angle. That's part of the definition of why we can use the negative reciprocal, which I'll talk about in a second, and you can find a link to explain that really well for Khan Academy on the Canvas page. So the thing that they figured out using geometry is this. If you take the gradient of, so M1 is the gradient of your original line, and M2 is the gradient of your perpendicular line. If you multiply them together, they should come out as -1. If your answer when you multiply your two gradients together isn't -1, it is not perpendicular. And so we can rearrange that equation to this second one here, which can be found on your cheat sheet. It is called the gradient of the normal. A gradient of the normal. And it's kind of underneath the graphs, but it is on there, so you don't have to remember it, you just have to be able to find it. But anyway, to find the gradient of a perpendicular line based on an original line, it is the negative reciprocal. So negative reciprocal. I feel like that is spelt wrong, but we'll roll with it. It is just that just means it is -1 on the old gradient. And we'll go through that in a sec. So here I've got a couple of lines, and we want to be able to tell if they are perpendicular. So what we do is we state the gradient of both lines. So remember, the gradient's the bit multiplied by your x. And then from our original definition, M1, M2 equals -1, if we multiply those two together, we come out with the answer of -1, so they are indeed perpendicular, and that's how we can show it. So down here we can see the gradient for our first one is 3/4. We need to find the gradient for our second one, so we're going to rearrange it. So we're going to take 3x off both sides first, then divide both sides by 4. So we can tell our gradient is -3/4. So then we multiply the two together, 3/4 times -3/4, and that does not equal -1, so these two are not perpendicular. Alright, and now this is the sort of question you are likely to get on an assignment, cheat sheet, assignment and exam, that sort of thing. So determine the equation for a line that is, that should say perpendicular. Let's just scribble that out. That should be perpendicular. That's what we're going for. To this line and runs through that point. Okay, so the first thing we need to remember is that we have a point. So if we're trying to find an equation and we have a point, we are going to use our point gradient equation. On your information sheet, just have to remember how to find it. So we've got our point, we just need our gradient. And because we're finding the gradient of a perpendicular, we know M2, which is our perpendicular gradient, is equal to -1 on our old gradient. So as long as you have a line, you can figure that out. And that's as straightforward as it is to find your gradient. So now we can solve it. Minus our y1, so remember if we label these, it makes life easier. 5 equals -1/3 x minus 2. Going to expand out our brackets. Okay, then we need to add 5 to both sides. And don't forget, we want to combine those two numbers so they are one number, which means we're going to change 5 so it's on a 3. So we times the top and the bottom of our denominator by 3 to get 15 on 3. and then we can come to our final equation. But using the point gradient equation is just like what we've been doing for normal linear equations. Okay, so now that's messy as hell. Here are the questions in the textbook that I suggest you do to make sure you're happy with perpendicular.